Here is Cesare Garlati again, and he'll be talking of taking this security thing, this topic, and talking about the purple spin on it, I guess, is a good way of describing it.
Yeah.
So, Cesare.
And I'll try to be as fast as possible. I know it's been a long day, and thank you for sticking to the end. Let's try to be a little bit interactive. So I try to wake you up. So who knows these guys? Raise your hand. You don't know Chris and Charlie? Really? Seriously? So let me tell you who they are. So they're very famous in the US, let me tell you. So these are the two researchers that actually figured out a way to remote control from their laptop 1.5 million cars in the US. Huh? How does it sound? And so they did more. They actually got a journalist, put in one of these jeeps, and really drove the journalist down and ditched him. Okay? So they got complete control on any single piece of the car. That's just fun? No. That's big money for companies that have to pay for recalls, for the brand, for the trust, whatever. But I would invite you to think something else, which is, by taking control of cars or trucks to that extent, you can kill people. You can literally kill people. So this is the more hacking, let's have fun. You can kill people, or you can get people killed. Who knows what this is? It's easy, it's written there, come on. Okay, so this is not a coffee machine. So when you go to the hospital and they put you the IV in your veins, that's where the drugs come in, okay? So this is in fact the #1 brand in the world, and what you see there is the #1 model they sold, and there's a past tense there. Why? Because some guy figured out a way to remote control from home the dosage of these devices. I'm not making this up, it's all documented, obviously. Again, you are noticing a pattern here. You can kill people, literally kill people. And actually, I had this conversation with the journalist, and he came up with a very smart way. So first, you get them in a car accident. So then you pick them up with your ambulance, and then you take them to the hospital, where then you, in the end, kill them, right? All of this will leave no traces, by the way. Let's call them 0 days. This is the new word of 0 days. And actually, I wonder if this has already happened, and we just don't know it, right? Okay, so the FDA, which is another of these 3 letters agencies that you guys hate so much, actually cares about your health, at least when you are in the US. And they forced this company to recall all of their equipment, which actually extended to 3, 4 other models they have there. For a brand that lives of this, to get the FDA to kick them out, it's a big damage, let me tell you, okay? Who knows what this is? Okay, so this is a major brand of some airliner, let's put it this way. What you might not know is who this Chris is. This is a tweet, this is actually real stuff. So this other Chris is another researcher. His focus is on security for avionics. He's been working in that space since ever. And so it's not clear whether he was able to control the airplane or not. What is clear is that by the time he landed, the FBI took him in custody. Now, I tweet a lot, but the FBI probably doesn't read my tweets. So turns out that he was actually able to affect the systems in the airplane, getting into the, what's it called, in-flight entertainment system.
That doesn't touch the real aircraft, that's segregated.
You see, so now the conversation is, why the FBI bother to actually stop by and take him away? Perhaps they know things that we don't. So this is a fact. The tweet and the FBI being there, well, I care because I fly on these airplanes. Actually, I fly with United. So when I see people opening up their laptops, I wonder a bit what's going to happen. Again, there's been cases very recently of airplanes that somehow mysteriously disappeared from radar, got their system disengaged, and so forth. Now, what I'm going to do with you is an experiment in 5 minutes, where I'm going to take just one of these cases. There's a pattern definitely there. And by the way, I had in one of my previous slides also 2 researchers that actually were able to remotely control rifles. So there is a brand of rifles that actually has a self-aiming device on top, which is a Linux device. And they were able to activate the Wi-Fi, get into the Wi-Fi, control the rifle, and prevent it from firing. But they were also able to re-aim it and actually get the target. Just go and search if you want to get all the details. So I focus on this incident because it's well documented, and at least in the US. But actually, I was in Asia 2 weeks ago, and it was very clear to them as well. So I'm surprised that in Europe you haven't heard much of this. Okay, so let's see how they do it, how they did it. Because it's not just about Chris and Charlie, it's about really a pattern there. And by the way, this is also what I was used to see on the data center kind of side of things. The Internet of Things is about connected devices. That's really the common characteristic. There is a network connectivity of some device. Most of them run Linux fine, or some version of it. So the first step is always to go and reverse engineer some closed source software, some proprietary software. And now I am at an open source conference. I don't have to convince you of the problems there. But something that people don't realize is that the big software vendors, the large one, number 1, 2, I worked for some of them, so I know something about that. Microsoft, Adobe, Oracle with Java. These are the most vulnerable pieces of software out there. Just go to the CV database and check the numbers. This is not an opinion, right? This is an easy one to explain to you. So they reverse engineered all the software that runs in what is called the head unit, which is the piece of hardware that controls all the car these days. And they were able to reverse engineer everything. They have a wonderful documentation available online. It's PDF, it's free, go and check it out. But if you use tools such as EDA, which is a debugger, or this kind of tools, Beanwalk, if you just want to open up one of these images, it's amazing what you can get out of it. So this concept of security by obscurity definitely shows its limit. So they figured out many different ways they could get into what they wanted, but then they picked one, which, as I explained before, is the low-hanging fruit. It's the shortest, least resistance pattern. They actually scanned those cars and figured out that, oops, someone left one port open. Raise your hand if you know what typically is connected to 66, 67. There you go. And I saw some presentation before explaining the good things you are doing there. So whoever did this forgot a couple of things. First, that port wasn't even needed, open. Second, that port was actually connected to the Sprint network. Sprint is the 3rd largest carrier in the US as we speak. It's something like 20 million devices connected on their network. So, oops, I have 20 million people that can actually access my car, and I left the, oops, it was unauthenticated. Why are you laughing? Unauthenticated. So it's open, unauthenticated, and exposed to some tens of millions of people. That's what's out there, okay? That's what security is these days. Well, what they did, they actually dropped their NSSH server, and that they were in. But they were in into the head unit. So they could do funny things, right? Change the radio station, turn up and down the volume. Okay, not nice. What's the next step? Lateral move, pivoting into something you really care about. That would be a server or a database in a data center world. Here, there is a chip that actually is connected to the CAN bus. The CAN bus is the system that controls all the parts of the vehicle, right? Anything from engine, brakes, steering wheels, everything is connected that way. So what they were able to do, and please guys here at the OpenWrt Summit, pay attention to these things. They were able actually to get all the software out of that, which is still firmware, right? Out of that secondary processor, which is a Renaissance, whatever is the model. Disassemble, decompile it, figure out what it does, and reflash it. That's the keyword, reflash it. They were able to feed a piece of hardware with some software that wasn't really intended to work in that way. Now, I have a car, I don't know you, but to know that someone can change the firmware of some pieces that actually interact with the brakes doesn't make me happy. Someone has to regulate that, I hope, okay? So let's be adult here. It's not like, oh, I cannot do that. No. Something needs to be possible, something doesn't have to be possible. Unless you like the idea to be remotely controlled when you drive your car. I don't. Okay, and I just explained you what they did. Then they moved, and they actually affected the piece of hardware that actually interacts, and they were able to do anything on that car. So I need to be a little bit fast, but look at the pattern here. Recognition, which is called typically in our small world, which includes a lot of things. In this case, typically it's hardware. So you get the firmware, and you try to reverse engineering. You can get the firmware in a couple of ways. You can just dump it out with JTAG. If you're familiar with JTAG, that's the way I do it. It's super easy. If you don't find the connectors, you make your own connectors, and there's plenty of information available online. But basically, you can take the processor out of the way. You just go hit the flash and gets everything out. That shouldn't really be possible. The other way, by the way, if they have any kind of updates, patch or whatever, typically these are not encrypted. They manage to change some things here and there. They don't want to go to the encryption process because it requires a key on the other side and key management. And this seems to be kind of skills that people are not really familiar with, okay? So in the end, recognition, typically these are connected devices. You exploit something at the network level connectivity, if it is IP, if it is whatever. There are many other protocols in this kind of connected devices.
Drive off the road, slam on the brakes. You could drive through a playground, kill a bunch of children, leave no trace, ruin somebody's life, and have a whole trail of death. You could use it for terrorist attacks. It's not just about the people in the car.
We don't disagree. It's the only thing. You cannot drive the car for much longer. So.
I don't see what the utility of having any kind of closed source anywhere in the stack is, because you simply cannot trust those corporations. And I really don't care if they think that that's what gives them a competitive edge, because clearly it doesn't. They had to do a major recall, and it's really just a publicity recall of the software update, where they're not changing anything about the fact that the infotainment system can slam on the brakes.
This is the point. Actually, I would have expected that question, especially in the case of the airplane. Why on earth you have the entertainment system and this is in the same box or connected to something so critical? Well, there is an easy answer. And I had this very question myself. So the answer is, in a modern car, in the cars that are in production today, not mine, not yours, 30 to 40% of the cost of the car is electronics. There you go. Which includes also connections and harness and installation. But anything you do to reduce anything which is 2 into 1, cut that cost in half if you extend to the old system, right? So obviously there is a desire to streamline and simplify and rationalize these things. The good news is that at the software level, there are ways to safely separate things. And if you route this into the hardware, I have one slide, but I don't want to run out of time. So let me just get to the next one. So just 1 second, so that you know what we are looking at Purple. And when I say we are looking at, it's not me. It's all the people who are contributing to the guidance that I showed this morning. I'm learning a lot myself going through this. So these are the pieces, the things that you might want to think of. That secure boot, which is really more than that, because the whole system to anchor down this, is intended to make sure that when you start a processor, unless the code is recognized as trusted, it doesn't come to life. That's very simple in terms of requirement. What it means that something is trusted, that's a totally different conversation. By the way, there's no concept of having one single key or one single entity because it's much more complicated, right? There is a delegation of keys. You have someone who makes the SoC, someone makes the board, someone actually installs the software, someone apps one of these blades. There has to be a process which is similar to what is the public infrastructure to actually delegate this. There might be a way to actually have something controlled by some certifying authority and delegates to some other entities. Absolutely. This is the model, right? So it's not lockdown is one, and that's it. That's not the model that is, I always like for that. Secure JTAG. Some of the vendors, by the way, already have some of this in place, but when you get into the virtualized world, it gets a little bit more complex. So what can you debug, what you should not be able to debug, what you can flash, not reflash. And by the way JTAG works, or in-circuit debugging to that extent, it gets you access to anything in the board. So it's not just the memory, it's everything else, right? You have control on the pins of the chip at that level, okay? Secure video stream, it's one of these requirements. It's considered security by some, as I said this morning, and I respect that. To their business, it's core, so it's very important. there are not just video streams, right? Any data stream, any flow of information can have a critical impact on systems. Linux containers, you know everything, you just learn everything, so we are really happy to put this into the picture. The hypervisor is something I'm going to show you in the next slide, because, so how do you do it? And by the way, the multi-tenant service provisioning is what keeps all of this together. These things are new, don't exist yet, or they are not being standardized yet. This works across the software stack, as I described, but something that probably is not immediate, transparent, evident to you is that if you look at a modern piece of hardware, there's no such thing as one processor, right? There are multiple processors. You know routers very well, right? So you have the switch, and then you have the main processor, other network processing unit. If it is more than a router, you probably have a GPU, probably have 2 GPUs. If there is a camera, because it's a car, you know, when you go when you back up, there are more units there. You need to secure this across these pieces of hardware, not across boxes. It doesn't work like that. It's one box. So the way it works is that if you can map these guests to all the individual hardware component and say, this is a radio component, so this guest can access it, the other ones cannot. I think that any regulator will be very happy to see something like that in place. You can flash, do, play, whatever you want there, because I can show you. Someone has been asked by the regulators to show how they prevent. Well, the way I prevent, I put together a virtualized environment where the radio is only controlled by this one, which is locked down, unchangeable, whatever you want. Everything else, open to the user for their freedom. I need to speed up a little bit, so I'll give you an example, right? So this is what I'm learning from the customers, real companies that actually implement this thing. So as of today, most of the boxes work like this. There's a provider, and there is one entity, one service, one throat to choke, right? So one responsible for everything. I live in San Francisco. Comcast has figured out a way to provide commercial Wi-Fi without buying a Wi-Fi infrastructure. How they do it? They just don't, that's the American way. So they don't even let their customers know. They just open half of that service up to people who walk down the street. And it's called Xfinity Wi-Fi. It's charged. So you're providing commercial service out of your box at home, and you don't even know. But you can opt out. That's the way it works in the US, right? There's always this opt out, and no one knows it. A ton of legal suits already in San Francisco. Not for security issues, interesting, but for the power consumption. These are 11N devices. They can suck up a lot of power. And so you see on the bill, it's $30 more. But think what can happen if someone puts child pornography into your PC at home, because you go straight to jail and your life is ruined, by the way. This thing happened before. I'm not making this up. Not in San Francisco and not Comcast. So BT, I understand in the UK, I've been told does more or less the same. So the world is coming up. It's a little bit more diverse. Someone mentioned in presentation this morning, right? So let's say this is the IoT Wall, right? So there are e-meters at home, whatever you have, right? So these things today either go on 2G, which is text messaging, basically, or they have some proprietary network. Does it make sense to use the Wi-Fi network connectivity already at home? Yes, it does. Can I get into that box? No, because you are the utility provider, PG&E, my place, and the box is provided by Comcast. Yes. Don't talk bad. If Comcast can make a dime out of that service, very interesting. So this is where it's evolving. And in the IoT space, there's this concept of IoT Hub. These small devices don't go with an IP address on the internet. It's very unlikely. Power, many other reasons, right? Processing power. So they go to some sort of local hub that eventually connects to something that has more power. So this is the model, and you have to consider that. I mentioned Netflix. Netflix doesn't have a box. Netflix is becoming a global reality. It's not just US. They don't have a box. There's no box to provide their service. They get into the Xbox, you name it, right? In your laptop, everywhere they can. They want a piece of the action there. I can tell you, I spoke with some of these entities. I don't want to put names there. They will tell you, I don't trust anything that is in that box. I don't trust anything else. I want to put my own thing. Well, you gotta get your own box. Well, but consumers don't want 45 boxes beneath their TV sets. Well, the interesting problem to solve, this would accommodate that. And by the way, leave slots open. I mapped them to, I did this slide. It's nothing to do with the actual ports there. It's just a way to convey the message, right? So how you do this? This is my final slide, and then we move on. Thank you for your patience, but I see the topic is somehow interesting, right? This is a kind of schema that resembles the model I just described before, right? So you have the hardware down there, and then you have software. But the first thing that the software boots, and in fact, this should actually come out of some ROM equivalent in the SoC itself, is the hypervisor. The hypervisor is what then boots everything else. It's really like cutting and slice whatever hardware you are familiar with no difference. But you see the power of this model, right? And we have the Linux representative here, right? So, and he got it right away. If that's small enough to be audited, that's secure enough. If it is 70 million lines of code, good luck with that, okay? Now, there is a little detail that I want to share with you because this is key. It's easy to think these things than to make them happen, right? This is actually commercial reality. These things already exist in commercial products. That IPC is key. So if you try to do inter-process communication with dbus, whatever, it's going to kill the system right away, okay? It's too heavy. And don't even think to go up to the IP stack to do any kind of socket communication. That's not going to work. If you have video stream there, it's 4K, it kills the whole thing, right? So what is needed is a dedicated IPC system mapped directly in memory. And so that's what we are looking at as a key component. It's not, the hypervisor is not just about a scheduler and policy management and protecting memories or whatever, and mapping the hardware, but it's also about an efficient IPC done in memory. Something that can support multiple video stream 4K, for instance, just to give an example, right? And I think this is my last slide. Yes. Thank you again. Happy to have continued this conversation over drinks. Just
Thank you.
next time.